Okay guys, welcome back. This next video is section 6.7, standard enthalpies of formation. What I'm going to do here is just video the actual slides. These are the same slides that are found on the wiki page, but it'll give me a chance to talk through them with you. First, a definition of standard enthalpy. Enthalpy change for the formation of 1 mole of a compound directly from its elements in their standard states, which is 1 atmosphere and 25 Celsius. So what it's saying is what the delta H value is when you're under those standard conditions. And oftentimes you'll see it with that little symbol that looks like a degree sign, which you can see right there, associated with the delta H. And the sub F is as in formation, not fusion, not like when we're talking about a phase change. So this is a different one. That's why it's a single F here, whereas it's FUS in the other one. And then the formula off to the side, delta H sub X, is just showing you that degree sign, which is also sometimes looks a little bit like a theta, means standard conditions, and the type of change, we're talking about formation. And where these come from is you're going to get a booklet from me in just a moment that's known as your reference booklet that lists all these values, and so they can be looked up. So an example of a standard enthalpy of formation would be the formation of carbon dioxide gas from its elements, carbon and oxygen, and its associated standard enthalpy of formation is negative 393.5 kilojoules. And that would be something that you could find in the reference book. Just like another example would be that N2 gas formed from its elements would have a delta H of formation of 0 kilojoules. Why? Because it's already in its elemental form. So any enthalpy of formation for any element is always 0, and a compound is calculated from its elements. Now, the nice thing is that we have these reference booklets that already have all of these values in them. So this is what I'm talking about when I say the reference booklet, and you're going to get those now. And within the reference booklet, let me just show you an example of how you can utilize this. So inside the booklet, there's a table of contents, there's metric prefixes, and look, all those beautiful ions are in there. And then when you finally get to the fifth page, you will notice that there's this set of thermochemical data, and it's not real focused here, and I apologize. So let me see if I can get a little bit better view with a different page. Well, you're going to open up your booklets and open up to page 6. It's still a little fuzzy. You'll notice that they're listed in alphabetical order. So on page 6, you've got nitrogen, and what it does is the first column is the elements, the compound or the elements formula, and you can see N2 gas has a value of 0. And then at the top of each column, it tells you what the units for each column are. The first one are, in fact, the heat of formations, and they're in kilojoules per mole. That delta G and S, those other two columns of numeric values, are something that we'll get to as part of the Chapter 6 supplement, which will be next week. So just for example, as I zoom in here on magnesium, you can see magnesium solid, which is an element, has a delta H value of 0, and then it has several common magnesium compounds with their associated state of matter listed and the appropriate delta H's for each. So at this point, we'll be using these booklets to look up the values in order to do this standard enthalpy of formation calculation. Now, what comes next? Well, there must be a formula that we're going to use, and that's called the summation equation, in order to be able to calculate the delta H for a reaction from these values in the booklet. And the beautiful thing about the summation equation, which is listed here, delta H of reaction equals the sum of the delta H's of formation of the products minus the sum of the delta H's of formation of the reactants, and that E is a sigma symbol, and it means sum of, just like it does in math, is that this equation can be used instead of Hess's law. So Hess's law, that's more of a process of thinking and puzzle-like in determining how to manipulate the equations. The summation equation is very standardized. You look up the values on tables. They're always done the same way, and it provides the same information. So the delta H of a reaction that's a result of a Hess's law calculation should be the same as the delta H of a reaction that's done by the summation equation. So let's look at example 610. Use the summation equation to determine the enthalpy of the following reaction. And I'm going to pause for just a second and then go back to writing on a piece of paper so that you can see this process carried through. And we'll be using the booklets as we go.